Jeffrey here again of Old American Iron. This time we're going to cover a different part of my addiction of old iron. This is my 1928 Harley Davidson Model JD. This is a picture before I got the fenders for it and before I got an original headlight for it. It is a collection of parts from all over the country they seem to have come from, and this is shortly after I finished building the sidecar body. I had the chassis for the sidecar but not the body. And the following is a slideshow of how I built the engine into a stroker motor. I'll start with a picture of a Harley JD engine. As you can see, it's inlet over exhaust. It's got side exhaust valves and overhead inlet valves. And you can notice the sign about projects in the background. That came from the shop of the older gentleman, my neighbor, where I got much of my heavy machinery from. As I said, one day I got the idea to try building a JD stroker. The stock stroke on a JD is 3 31/32, and I had a set of used S&S 4.5-inch stroke flywheels for a panhead, and I thought there should be a way to adapt them. As you can see in the photo, number one is the tapered bushings I made in order to fit on pinion shaft number 2 and then to fit into the flywheel on number 3, as the JD shafts are smaller in diameter than the panhead shafts. And heavy shaft with the hole in it in the center of the picture, that's a piece of an old Ford truck axle shaft, and I figured that would be some pretty good material to make them out of. In this picture, the arrow number 3 shows where I installed the pinion shaft, which drives the camshaft on the right hand side of the motor with its bushing into the right side flywheel. And number 1 shows the bushing I made for the crank pin to fit in to adapt the crank pin to the flywheels, and number 2 shows the bushing for the other end of the crank pin along with the washer I had to make in order to tighten it into the larger diameter of the flywheel. In this picture you can see the rod bearings number 1, which fit into the big end of the connecting rods number 2, which slide over the crank pin number 3 and in turn get installed into the hole number 4 of the 2 flywheels to form the crankshaft. And in 5 you can see the bushing I made for the main shaft, which is the drive sprocket side of the flywheel, fits into hole number 6. In this picture you can see the assembled crank assembly ready to be put into the engine, and you can see the piston that the rod is setting on the bottom. You can see the piston has been trimmed, and there's a little notch left in the skirt of the piston where the web of the piston will fit down through the baffles in the crankcase of the JD motor. These were modified panhead pistons. Here's another shot of the crank assembly completely ready to be installed into the crankcases, and also are the 2 cylinders. I don't have any pictures of the repairs, but I welded quite a number of the fins onto the cylinders as I started out with a real bad set I had for this experimental project. And as you can see on Harley JDs, the heads are non-removable. The head and cylinder is all one. So when you bore the cylinder, it's a blind hole you're boring into, so you have to set up the boring bar very carefully not to bottom out when you're doing it. Here's a shot of the engine. I'm just mocking it up here to make sure everything fits properly, and I was fitting it to make gaskets, etc. As you can see, the flywheel crank assembly isn't installed in the crankcases yet. Here's a shot of the other side of the engine. That's the gear case cover, which has the camshaft and the gears underneath, which go back to run the generator, which mounts on the back side of the engine. As I say, it's just being mocked up to make gaskets and make sure all the parts are there and that everything fits. Here's a shot of modifying the pistons. I chucked it in the lathe first to shorten the piston, but then I just used it to hold the piston as I put a notch on each side. You can see there's a steel web between the skirts of the piston to keep it from expanding, and I had to notch the piston around that steel web, and the 2 little tabs where the web is fit down through a slot in the baffles of the crankcase. More displacement means more carburation, so I had to build an adapter in order to on a different carburetor. I ran it with a Bendix, but it currently is being run with a S&S Super E. This started out as just a block of aluminum, but I had to build it up on two sides to make it wide enough to match up to the carburetor. Here's another shot of the adapter after I bored the hole through it and I trimmed off both ends of it somewhat. Now it's time for assembly. This is a shot of the crank assembly set up in the left side crankcase. This is a shot of the crankcases fully assembled and the cam gears installed. And if you look closely, you can see the lifters do not run directly against the cam. They have what's called an indirect cam action. There's a pin in the center that has levers, and then there's rollers on the end of those levers that roll against the cam lobes, and the lifters go approximately halfway in the middle of those levers. Here's a shot of the engine with the front cylinder installed and the rear cylinder waiting to be installed. Here's a shot of the engine with both cylinders installed and the exhaust valves and valve covers installed and the gear case cover installed with the gears that go to the back of the engine to run the generator, and the second gear from the left has a worm gear sticking out from it which runs the oil feed pump. Here's a shot of the engine fully assembled. As you can see, I set it up with a degree wheel and a micrometer for finding top dead center. Originally, a JD did not have a timing mark. The service manual called for measuring the top of the piston, whether it be an eighth or a quarter or 3/16 or whatever, before top dead center to set the timings. So I set it up with a degree wheel and put a mark on the flywheel that you could line up with the drain hole on the bottom of the engine, so that when I set timing from in the future, I could put a degree wheel on it and do it in terms of degrees. After all the modifications, the engine displacement was originally 74 cubic inches. Now it's 83.5, and with larger displacement into the same combustion chamber, it upped the compression ratio from 2.4 to 4.2 to 1, and it has very nice deep throaty sound. I thought I'd finish this slideshow up with a shot of the old lathe I did this precise work on. It shows you can do mighty fine work even on a big old lathe with a lot of wear. And thanks again once for watching, and Keith, you know who you are. This video is for you. Bye now.